Good morning students. Today we will discuss about Planck's law or Planck quantum theory or Planck radiation law. Okay. So last class we have discussed about black body radiation. In the black body radiation we have discussed about black body laws. So we have discussed about Wien's law. Wien's law is applicable for shorter wavelengths and Rayleigh-Jean's law. Rayleigh-Jean's law is applicable for longer wavelengths. So there is no single expression to explain for both shorter and longer wavelengths. Okay, so Planck radiation formula describes, he has derived theoretical expression for the energy distribution. He has derived theoretical expression for the energy distribution which holds good for shorter wavelengths and longer wavelengths. Means it can explain for shorter wavelengths and longer wavelengths. Okay, now in order to derive this expression, he made some postulates. He made some assumptions. So what are the assumptions? See here, according to Planck quantum theory, according to this theory, energy is not emitted continuously. It is not emitted continuously. Means it is emitted in discrete packets. It is emitted or absorbed in discrete packets which is called as quanta or photon. So energy of each photon is given by E is equal to h nu. Energy of each photon is E is equal to h nu, where h is Planck's constant and nu is the frequency. Now if we see for number of atoms, energy is given as nh nu. N can take the values 1, 2, 3, so on. If n is equal to 1, the energy is h nu. If n is equal to 2, the energy is 2h nu. If n is equal to 3, the energy will be 3h nu. So these are the postulates made by Planck. Next, another assumption is atoms. Atoms are considered as vibrators. Atoms are considered as vibrators or oscillators. So atoms are considered as vibrators or oscillators. So these are the assumptions made by Planck. Next, in order to derive spectral energy density, our aim is to derive spectral energy density. So in order to derive spectral energy density, let us consider, let Nn be the total number of atoms. So Nn be the total number of atoms. So these Nn number of atoms are having energy En is equal to nh nu. So these Nn number of atoms are having energies En is equal to nh nu. Now according to, see here, how these atoms are arranged in different energy levels. So one atom is arranged in one state, or two atoms are arranged in one state, or three atoms are arranged in one state. That can be given by how many atoms are arranged in one energy state is given by Maxwell-Boltzmann distribution law. So from Maxwell-Boltzmann distribution law, the number of oscillators with energies En is given by N is equal to N naught into e power minus En by kT, which is equal to N naught into e power minus nh nu by kT. So here En is nh nu. So in place of En we have substituted minus nh nu. This is from equation 1. Okay. Now what is N naught? N naught is the number of atoms. Atoms are considered as oscillators. So it can be number of atoms in ground state. Now see here energy is discrete. Means here energy is not continuous. It is discrete. So it will be having different energy values. If we want to take average energy, so if I want to calculate average energy of each oscillator, So average energy of each oscillator is given as, see here, average energy is represented like this in quantum mechanics. Average energy is given as E is equal to, now sum of the energies, sum of the energies of all oscillators, sum of the energies of all oscillators divided by number of oscillators, sum of the energies of all oscillators divided by number of oscillators. So average energy is given as sigma n is equal to 0 to infinity sum of the energies of all oscillators, means here nn number of particles are there which are having en number of en energy. So I can give average as n1 e1 plus n2 e2 plus, so like that I can give. So sum of the energies of all oscillators is given as n n en divided by sigma n is equal to 0 to infinity, total number of oscillators is nn. Now which is equal to sigma n is equal to 0 to infinity. What is nn? So we know nn is from equation to n naught e power minus nh nu by kt. So I can write it as n naught e power minus nh nu divided by kt into en is nh nu divided by sigma n is equal to 0 to infinity, nn is n naught into e power minus nh nu by kt. Okay, now n naught, these are not related to small n, so bring outside. So this n naught get cancelled. Now average energy, is given as, so see here, average energy is given as E is equal to sigma n is equal to 0 to infinity e power minus nh nu by minus nh nu by kt into nh nu divided by sigma n is equal to 0 to infinity e power minus nh nu by kt. Okay, so what I have written, sigma n is equal to sigma so we have written sigma n is equal to 0 to infinity e power minus nh nu by kt into nh nu divided by sigma n is equal to 0 to infinity e power minus nh nu by kt. So this is the expression. So now average energy is equal to, now you substitute n is equal to 0. If I substitute here n is equal to 0, e power 0 is 1. But here n is 0. So 0 into something will be 0. 0 plus, if I keep n is equal to 1, I can write it as e power minus h nu by kt into h nu. Plus, if I substitute 2, minus 2h nu by kt into 2h nu. Plus, if I substitute 3, e power minus 3h nu by kt into 3h nu divided by, so divided by, now here also you substitute n is equal to 0. What happens? E power 0 is 1. 1 plus e power, you take n is equal to 1. So if I take n is equal to 1, I will get e power minus h nu by kt plus e power minus 2h nu by kt plus so on. So this is the expression we got. Now, so see here what we got, sigma, I mean energy, average energy is equal to 0 plus e power minus h nu by kt into h nu plus e power minus 2 h nu by kt into 2 h nu plus e power minus 3 h nu by kt into 3 h nu plus so on divided by 1 plus e power minus h nu by kt plus e power minus 2 h nu by kt plus e power minus 3 h nu by kt plus so on. So let us consider x is equal to e power minus h nu by kt. Now what I am taking x as e power minus h nu by kt. Okay. Now if I substitute in the above equation, so substitute x value in above equation. So substitute x value in above equation. We'll get it as average energy E is equal to, so see here, e power minus h nu by kt means x into h nu plus e power minus 2 h nu by kt means x square into 2 h nu plus x cube into 3 h nu plus so on divided by 1 plus e power minus h nu by kt means x plus x square plus x cube plus so on. So we'll get average energy as, which is equal to, we can take x h nu common. So if I take here x h nu common, we'll get it as 1 plus 2x plus 3x square plus so on divided by 1 plus x square plus x cube plus so on. So average energy is given as x h nu into 1 minus x whole power minus 2 divided by 1 minus x whole power minus 1. So see here, this is the numerator term is the expansion of 1 minus x whole power minus 2. Denominator term is the expansion of 1 minus x whole power minus 1. So I can write it as x h nu divided by, so see here, if I take this 1 minus x whole power minus 2 to denominator, what I will get? 1 minus x whole power plus 2. So plus 2 minus 1 will be plus 1. So 1 minus x. So we got average energy E is equal to S x h nu divided by 1 minus x. So now average energy. So how much we got? X h nu divided by 1 minus x. Okay. So implies average energy E is equal to h nu divided by, I can write this one as 1 minus x by x, because this is, I can write numerator as denominator. So I can write it as h nu 1 by x minus 1. So this is here 1 by x minus x by x is 1. So h nu x whole power minus 1 minus 1. Okay. So implies average energy E is equal to average energy. See here, average energy, like these brackets we need to use. Average energy E is equal to now average energy E is equal to h nu divided by what is the value of x? H nu divided by, we know the value of x is, we have taken e power minus h nu by kt. This is x. Now what will be x power minus 1? What will be x power minus 1? So x power minus 1 will be e power h nu by kt, h nu by kt minus h nu by kt minus 1. So this is the average energy of each oscillator. This is the average energy of each oscillator. This is represented by equation 3. Okay. Now we will continue next part in the next lecture. Thank you.